So our next topic is on alcohols and ethers. So we're actually getting into some different functional groups that are now going to contain oxygen. So let's take a look at what these are. So remember that your functional group is any atom, group of atoms, or organization of bonds that determines the specific properties of a molecule. Okay? It's usually the most reactive portion of a molecule, and its presence signifies certain predictable characteristics. So in some molecules, the functional group is actually a double or a triple bond. We saw that with alkenes and alkynes. When we look at alcohols, we're going to look at the hydroxy group. So OH is the hydroxy group. So that's an oxygen and a hydrogen together. So when you see that, you'll know you have an alcohol. If you see OR, so an O bonded to another carbon or the rest of the chain, it's called the alkoxy group, and that's what you're going to see in ethers. And then a C with a double bond to an oxygen is a carbonyl group, and we're going to see that in our next note on aldehydes and ketones. So let's go to alcohols. So the functional group, I've already said, is OH, also called the hydroxyl group. When we name them, it's pretty straightforward, but now we have to look at the parent chain that has the OH in it, okay? So what we do is we take that chain and we replace the ending with OL. So instead of, here we've got a 1-carbon chain, so that would normally be methane. So it says here, replace the E with OL. So we're going to take out the E and call it methanol. This we would start off by calling it ethane, but now that it's got the OH on it, it's called ethanol. And this is called butanol, okay? Now we're starting to get complicated because that OH can actually end up on the first carbon in the chain, like it does here. It's attached to that first carbon. What happens if it's attached to the second carbon? Well, then we use our numbering system to specify that. Okay, so the position of the OH group is indicated for different structural isomers. We have to use numbers. Oh, sorry, I wrote butanol there. It's propanol. My mistake. So we actually have to write 1 propanol instead to differentiate between the 1 and the 2. So we'll look at some more examples. You can also have polyalcohols, and that means that they contain more than 1 hydroxyl group. So what happens usually if we have more than 1 double or triple bond? We use di and tri. So same thing is going to happen here. The ending is going to be a diol for 2 OH groups and a triol for 3 OH groups. So the example I give you here is 1,2-ethane diol. Oh, and I thought I had a picture of that. So 1,2-ethane diol, I'm going to draw that up here. You have ethane, which is 2 carbons, and you have 2 OH groups, 1 on carbon 1, and 1 on carbon 2. And then the rest are all H's. Just like that. Hydroxyl groups can also be considered as an added group or a branch to a parent chain. If that's the case, we call it hydroxy. So for example, 1,2-dihydroxybenzene. If we look at, oh shoot, sorry, I thought, again, I had a picture of that. Let me go back. So again, if I draw that one, I'll draw this one in blue. Sorry, this is going to get kind of crammed. We'll do that all the way up here. So if I'm doing 1,2-dihydroxybenzene, that looks like this. Here's your benzene ring, and I've got an OH here and an OH here. So if we look at this molecule, you really can't name it another way. You have to take into account that there's a benzene ring in there. You could call it a phenol, but you still have to name the second OH group that's on there. So if you can't name, if you see an OH group and you can't name it as an alcohol, then you're allowed to use the hydroxy name instead. So properties of alcohols. The OH group is very, very polar and actually capable of forming hydrogen bonds. So remember, when hydrogen is bonded to oxygen, nitrogen, or fluorine, it can make hydrogen bonds because of the partially positive and partially negative charge. Oops, that's negative. Oxygen, oops. Let's do this. Partially negative. So that partial negative on the oxygen will be attracted to a partial positive on another hydrogen. That intermolecular force between those two molecules is your hydrogen bond. Okay. It Can also form hydrogen bonds with water, obviously because water is very polar and can also form hydrogen bonds. So it will dissolve in water very, very easily. But alcohols with 5 or more carbons are usually not very soluble in water. Okay, why is this? That's because it's got a long nonpolar hydrocarbon chain. So if I've got 5 carbons and then an OH, sure, this end of the molecule is polar, but it's only a small portion when you consider the rest of the molecule. So as you get longer and longer chains, the molecules in alcohols actually become less and less polar. All right, so again, due to the nonpolar hydrocarbon chains, the long-chain alcohols are soluble in nonpolar solvents. And then OH groups in alcohol can form hydrogen bonds with themselves, leading to higher boiling points in alkanes of similar molar mass. Okay, because remember in alkanes you only have those London dispersion forces. You have no dipole-dipole or hydrogen bonds happening. So because alcohols can make those hydrogen bonds, their boiling points and melting points are significantly higher than alkanes. All right, types of alcohols, primary, secondary, and tertiary. We looked at these really quickly in your lab, but hopefully you had no idea what they were. So now you're going to be able to start to piece those put those pieces of the puzzle together. So basically what happens here is we depend on the location of that hydroxy group, okay? If it's a primary alcohol, then the OH group is bonded to a carbon that is only bonded to one other carbon atom. So follow that. Your OH group is bonded to a carbon that only has one other carbon atom. That means that the other 2 things on this carbon are hydrogens. Secondary alcohol, the OH group is bonded to a carbon that is bonded to 2 other carbons. So here's your OH. It's bonded to a carbon that has 2 more carbons on it. Okay, that means that the only other thing on it is 1 hydrogen. Tertiary alcohol is when your OH group is bonded to a carbon that is bonded to 3 other carbon molecules, okay? So those are your differences. Here, let me erase these because this is getting messy because now we've got a diagram at the bottom. So if we look down at the bottom here, a primary alcohol, this OH group is bonded to a carbon that's only bonded to 1 other carbon. The other 2 things are hydrogens. So because this carbon only has 1 more carbon attached to it, it's a primary alcohol. Here's an example of a hydroxyl group. It's bonded to a carbon, and this carbon has 2 other carbons attached to it. We call that a secondary alcohol. And in the third one, here, let me move this. There we go. In the third one, your carbon here is bonded to 3 other carbons, so we call that a tertiary alcohol. Now, why is that important? It's important when we look at the reactions of alcohols. So, first we're going to look at synthesis of alcohols. How are alcohols made? Basically, we can use a hydration reaction, okay? So that is the addition across the double bond from an alkene. And what we can do is add water. So hydration adds water. We need sulfuric acid as a catalyst. And where's my example? There it is. So again, we've sort of seen this before. In an alkene, this bond can break. And you can put an H on one carbon and an OH on the other. Okay. You're going to put the H on the carbon that already has more hydrogens because it has to follow Markovnikov's rule. So the OH would go here. So that's how I got this final structure at the end. Okay, and now that it has the OH group on it, this is an alcohol. Can you guess if this is a primary, secondary, or tertiary alcohol? Take a look. This carbon is bonded to how many other carbons? 1, 2. It's a secondary alcohol. You should be able to identify those. All right, another way to make alcohols is the fermentation of sugars. So yeast, which is a fungus, can break down sugars in the absence of oxygen to produce carbon dioxide and ethanol. And this is actually how we make alcohol that is drinkable. So here is your glucose. Okay, and what happens is it's broken down into carbon dioxide, and in this case, ethanol. You don't need to fully understand how or why this works, but I just wanted you to show you that this is possible. Oops, I just hit end. Sorry. Let's go back. There we go. More reactions of alcohols. So, dehydration reactions are elimination reactions. So this is, we start with an alcohol and we can go backwards to make the alkene. So again, if we add enough acid and heat, what's going to happen? It's an elimination reaction. So we take two things off, and then that will close and make the double bond. Okay? And again, one propanol, we're going to take off the OH on this carbon, and one of the H's here. That's how your H2O is made, and you're left with an alkene. So that's very similar to what happens with your alkyl halides forming an alkene. Okay, you need very high temperatures and an acid catalyst. H2O is eliminated, and a double bond is always formed. So that's sort of what's happening really quickly in that reaction. Hydrohalogenation reactions. This is when it reacts with hydrogen halide, HX, to produce an alkyl halide in water. Okay, so this is kind of, you can sort of look at this as a substitution reaction. So we're basically going to take this OH and the halogen, and they're going to swap. Okay, so when that happens, the halide ends up on your alkane chain, and you're left over with water. So that's another possibility. All right, so let's do some practice. Draw the following alcohols and state if they are primary, secondary, or tertiary. I'd recommend, if you want, to pause the video right now, because I'm going to go through the answers right away. Try these out. Try to predict the products of that reaction at the bottom. And then when you've got them, press play and see if you get them right. This is sort of a way you can do your own, check your understanding at home. So if you want, pause now. If we go through the answer for A, we have to draw one pentanol. So pent means 5 carbons. All means I have an OH group. The OH group is going to fall on carbon 1. So I start by drawing my 5 carbons. And I know I have an OH group on carbon 1, so I can use this as my carbon 1 or this as my carbon 1, doesn't matter. I'll use the last one. So I put my OH group there. And then if you want to fill in the rest of your H's, you've got 3 H's on this carbon, 2 here, 2 here, 2 here, and only 2 here because this carbon is already bonded to another oxygen. 2,3-dimethyl-2-hexanol. So again, when you've got a big long name, start at the end and work your way back. So let's start with hex. Is 6 carbons, 3, 4, 5, 6. I've got all, so I know I've got to put an OH group, and I'm going to put it on carbon 2. So I'm going to call this 1, 2, 3, 4, 5, 6. There's my chain. So I'll put an OH group here. There's my alcohol, so all this is basically done. So now I have to put dimethyl, 2 methyl groups on carbons 2 and 3. So I'll put them here, CH3, CH3. Fill in your H's, and you're done. Predict the products of the following reaction. So this is an example that I gave you at the bottom of the last slide. Hydrohalogenation, we're going to swap the alcohol and the halide. So you're going to end up with CH3, CH2, 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 and instead of OH, I now have an I on here, and I'm left over with HOH or H2O. So hopefully you got those as well. All right, ethers. The functional group in this case is ROR prime. So that means that you have one chain on one side of the R and a different chain on the other side of the O. Absence of the OH groups. Okay, so in this case, the O actually ends up being between 2 carbon atoms. So that means if we don't have an OH, we cannot make hydrogen bonds. So it's slightly polar due to that carbon-oxygen bond. And what's going to happen is that carbon-oxygen-carbon bond, that COC bond, is going to be V-shaped or bent. So we do have a little bit of polarity there. Okay. Boiling points are lower than the analogous alcohols, but higher than hydrocarbons, again, because we do have some polarity with that carbon-oxygen bond. They're pretty unreactive, though. They're pretty stable as they are. And they are able to mix with polar and nonpolar solvents because they have a polar CO bond, but then the rest of the carbon chains are nonpolar. So, naming ethers. Here's your rule. These ones are a little bit different. You have to add oxy to the prefix of the smaller hydrocarbon chain, and then join it to the alkane name of the longer. So, what you have to do is whenever you see an ether, you've got an O in the middle of two C's. Find the smaller hydrocarbon group and name it first. So in this case, I've got one carbon here, one carbon here. So I've got methane sort of on either side of my carbon. So I'm going to call that meth, oxy, methane. In this case, they're both the same size, so I don't have to worry about the smaller and the larger hydrocarbon group. Same thing here. I've got an eth group here and an ethyl group here. So how do I name that? Oxyethane. Here now, I've got two different chains. So one is a meth group, and one is an ethyl group. You name the smaller chain first, meth, then use oxy, then name the rest of the chain, ethane. If you wrote for this one, oxymethane, that is wrong, because you have to put the smaller part of the chain. In this case, one carbon is shorter than two carbons. You have to put the smaller part of the chain first. Okay? As the molar mass of alcohols or ethers increases, the boiling point increases. And then what ends up happening is your alcohols and your ethers are actual structural isomers of each other. So remember what a structural isomer is. It means you have the same formula, but the way that the bonds are arranged are different. So if you look here, this is ethanol. Has two carbons and an OH group. This is methoxymethane, same as up here. Okay, but again, we have two carbons, and in this case, the oxygen's in between the two carbons. Okay, they have the exact same formula: 2 carbons, 6 hydrogens, and 1 oxygen. But their boiling points are drastically different. Why? Remember, your alcohols can form hydrogen bonds, making your boiling points much higher. All right, just for fun. Another way to name ethers is by placing the prefixes for the two alkyl groups in front of the word ether. So, as from this point forward, you can actually name ethers in two ways. I don't care which way you pick. I will most of the time give you this method here, but if you want to try, some people like this way better. So on the last slide, this was methoxyethane. What you can do is actually call it methyl ethyl ether. Okay, the next one would be ethyl, and then 1, 2, 3, 4 carbons, so that's butyl. So that would be ethyl butyl ether. Now, again, just for fun, just to give you guys a little giggle, what is this? A propyl people ether. Hopefully you've heard of the song, The Propyl People Eater. Anyways. That's where it's coming from. So how do we make ethers, sorry? It's a condensation reaction. Let's put that up there. 2 alcohol molecules react together to form water and an ether. You need to have sulfuric acid. So here's what happens. Here I've got 2 molecules of methanol. My OH groups, I'm going to sort of rewrite this up top just to show you a little bit more as to how they react together. So here are your 2 alcohols. Those 2 ends of the molecule will react together. You will take off an H2O molecule. So here's 2 H's and 1 of the O's. That is your HOH or your H2O. What's left? You have a bond from this oxygen to the first carbon and then a bond to the second carbon. So that's how I end up with that oxygen in the middle. All right, so that was sort of a quick explanation. If you have questions about that, hopefully I can answer them in class when we go through some activities. Your flow chart now, we've added in alcohols over here. We've also added in the reactions of alcohols. So we've looked at hydrohalogenation to make an alkyl halide. We've looked at the dehydration or the elimination reaction to make an alkene. And we've looked at condensation to make an ether. And that was our other sort of new compound today. Next, we're going to look at how alcohols can also form aldehydes and ketones and even carboxylic acids. Okay, so that's going to be in the next couple of notes that you get. So I'll see you in class and clear up any questions that you have.